So in this video we're going to use the method of undetermined coefficients when we have a polynomial driving function. So here I have a second order linear non-homogeneous differential equation. So my driving function g of x is a polynomial. So it's a two-step process for solving this differential equation. First, we need to solve the homogeneous case. We have a non-homogeneous equation, but we need to solve the homogeneous equation y double prime minus 5y prime plus 6y equals 0 first, because our solution is going to have the form y complementary plus y particular. So we need the solution to the homogeneous case. We need the general solution, or we need the solution that's a vector space, and then we're going to add a particular vector to that solution so that we move our solution space into the correct position. So first we solve this, and then we want to remember that we get a characteristic polynomial out of this. So my leading coefficient's 1, so it's going to be 1r squared minus 5r plus 6 equals 0. So we need to find the roots for this characteristic polynomial. So we might try factoring it. We might try completing the square. We might try using the quadratic formula, so any solution method that we know for solving a second degree polynomial. So in this case, it looks like it factors as minus 3 minus 2. And that tells us that we're going to get two roots. We're going to get a root of 2 and a root of 3. So our complementary solution, the solution to the homogeneous differential equation, is going to look like c1 e to the 2x, I'm using x not t, plus c sub 2 e to the 3 times x. So there's the complementary solution. So that's always going to be step 1. Then step 2 is we deal with, and this is the undetermined coefficients piece of the solution process, we look at the function g of x. And if the function g of x is a second degree polynomial, even if the other terms are missing, what we're going to do is guess that the solution, we make a guess, and we guess that the solution is going to look like a second degree polynomial, ax squared plus bx plus c. We make this as our guess, and then we know if this is a solution when we plug in the first and the second derivatives of the solution, that the solution will need to equal g of x. So it needs to simplify to the stuff on the right hand side. So what we're going to do then is take the first and second derivative of our guess, which is a second degree polynomial. So we get 2ax plus b, and then we take the second derivative, which is just twice a. Now what we need to do is plug these into our differential equation. So our differential equation was y double prime minus 5y plus 6y equals the 12x squared plus 4x plus 2. And I'm going to tuck this complementary solution out of my way. Y complementary c sub 1 e to the 2x plus c sub 2 e to the 3x. That way I can get rid of the work that I did to come up with that. So I've got space on the board to write. So right here, plug in y double prime, which is 2 times a, minus 5 times y prime. It needs a prime on it, 5y prime, and y prime gets replaced with twice ax plus b, plus 6 times y, so it's going to be 6 times the ax squared plus bx plus c, and this all has to add up to g of x, the driving function. So what we want to do is group x squared things, group x things, and group constant things. So we need to simplify things a little bit. We get minus 5 times 2 is minus 10ax, minus 5 times b is minus 5b, plus 6ax squared, plus 6 times bx, plus 6 times c, and this has to add up to the 12x squared plus 4x plus 2. So now group things. We have a x squared term here, so we have 6ax squared plus, now get everything that goes with just x's. So here's a minus 10ax plus 6bx. So we factor the x off, and we'll get 6b minus 10 times a. And then combine anything that's a constant. So plus, I have 2a minus 5b plus 6c. And it has to equal the polynomial sitting here. And so what we're going to do then is equate coefficients. So we know that if ax squared plus bx plus c is a solution, then 6a will need to equal 12. The coefficient on x squared here will need to come from the coefficient on the x squared term here. So that tells us that 6a has to equal 12, which means a is going to need to equal 2. So we'll put a star by that. Now the coefficient on x over here, which is 6b minus 10a, that's going to need to equal the coefficient on the x term for the driving term. So this needs to equal 4. But a is equal to 2, so I can replace the a right here with 2. So we're going to get 2 times 10 is minus 20. And then I can add the 20 to both sides to get 24 over here. And then divide both sides by 6. And that's going to give us b is equal to 4. So we'll put a little asterisk by that as important. So here is important, here is important. And now finally we go to the last, the constant term has to equal the constant term here. So we get 2a minus 5b plus 6c must equal the 2. But now we know what a is. A is equal to 2, so 2 times 2 is 4, minus b is 4, 5 times 4 is 20, plus 6 times c has to be 2. Add 16 to both sides. 4 minus 20 is negative 16. Add that negative 16 to both sides. We'll get 6 times c equals 18. And then divide both sides by 6. We get 3. And this guy's important. So that tells us we guessed that our solution looked like this. So now we know our particular solution. Give myself a little space here. We know our particular solution. We were really guessing why particular. The particular solution that we can plug in here to get the driving function g of x is given by 2, a is 2, 2x squared plus b is 4, 4x plus c, c is equal to 3. And so our solution is going to be y complementary, which is down here. It's the solution to the homogeneous equation, c sub 1 e to the 2x plus c sub 2 e to the 3x plus our particular solution, which is 2x squared plus 4x plus 3. So here's the general solution to this differential equation. Were we given initial conditions, we could attempt to solve for our constants. So a final comment. So if I erase this mess for a second. So the other thing, just to point out, and this isn't necessary, but to point it out in case you want to do it this way, if we set 6a equal to 12, right, we equate the coefficient on the x squared term. 6a equals 12. I'm going to write it like this. And then we do 6b minus 10a, so it's really minus 10a plus the 6b, which is the coefficient on the x term. This needs to equal the 4. And then the third one here I get, it's minus 10a, and the third one here I get, the constant term is 2a minus 5b plus 6c, which has to equal the 2. And so what we want to recognize is we do have a system of 3 equations in 3 unknowns. This is plus 0c, this is plus 0b plus 0c. So from your linear algebra background, if you wanted to, you could make this into a matrix, right? We could do 6, negative 10, 2. We could do 0, 0, negative 5, 0, 0, 6, augmented with the constant vector 12, 4, 2. And we could solve for A, B, and C because we have A, B, C columns by putting this matrix into reduced row echelon form from linear algebra. So just, you know, in this particular case, it wasn't a problem because I contrived this problem to give myself integer solutions. So I constructed a differential equation that was going to work out nicely. If things were looking a little bit ugly, and maybe I was going to get some nasty fractions or something, and I didn't want to have to deal with it, hey, make a system of equations, put it into a matrix, and let your computer algebra system put that matrix into reduced row echelon form for you. In linear algebra, for us, we use GeoGebra, but whatever tool that you use, go ahead and use it. Use what you know from other courses to simplify your life if you find that is something that you want to do.